Welcome students. We've got an exciting concept to tackle today. Let's dive straight in. In our last lesson, we explored estimation. Have you ever measured something, like the length of your desk, and ended up with a slightly different result than someone else? For instance, you measure the desk to be 3 meters, but your friend says it's 3.1 meters. How accurate are the measurements? Does the small difference really matter? Well, in many situations, even the tiniest difference can be important. This leads us to what we will learn today: how to measure the degree of accuracy in measurements. Join me as we dive into this lesson. Degree of accuracy is a measure of how close and correct a stated value is to the actual value. The accuracy of a calculated value may be affected by the use of significant figures, or rounding off, in measurements. Sometimes, it seems that an answer, found at an intermediate stage of a calculation, may need to be rounded off, before it is used in a subsequent stage. However, since such rounded off values affect the degree of accuracy of the result of calculations, it is generally not advisable to round off intermediate values. Let us solve an example together to understand how this works. Example 1. Calculate the area of a circle with a radius of 3.5 centimeters. Leave your answer in two significant figures. Solution. Remember the formula for finding the area of a circle. Area of a circle equals pi multiplied by the square of the radius. Recall that pi is equal to 3.14. So let's write, where pi equals 3.14 and r equals 3.5 centimeters. Let us substitute the values into the formula. That gives us 3.14 multiplied by the square of 3.5 centimeters. We know that the square of a number means multiplying the number by itself. So, let's open bracket first. Equals 3.14 times 3.5 centimeters times 3.5 centimeters. Use your calculator to solve that. The answer is 38.465 centimeters square. Note that when we calculate the area of a shape, we denote the result with square after the unit of measurement to indicate that the value represents an area. Now let us round this result to two significant figures, as stated in the question. Recall how to round off numbers as covered in Lesson 8. The first two significant figures are 3 and 8. Since the first digit after the decimal point, 4, is less than 5, we will round it down to 0. Therefore, our answer is 38 centimeters square to two significant figures. Let's move on to a rough estimate and see how our results compare. We will use these values from the previous slide to solve for the rough estimate. First, let us approximate the values of pi and r to one significant figure. The significant figure in the number 3.14 is 3. Since the first digit after the decimal point, 1, is less than 5, we will round it down to 0, giving us 3 to one significant figure. We will do the same thing for the value of r. The significant figure in the number 3.5 is 3. The first digit after the decimal point is 5, so we will round it up to 1 and add it to 3, giving us 4 to one significant figure. Now, let's substitute the rounded values into the formula for finding the area of a circle, as stated above. That gives us 3 multiplied by the square of 4 centimeters. Now let's open the bracket. Equals 3 times 4 centimeters times 4 centimeters. Use your calculator to solve that. The answer is 48 centimeters square. Comparing our exact answer, 38 centimeters square, and our rough estimate, 48 centimeters square, we notice that the rough estimate is larger. The difference arises because rounding off at the start reduces the accuracy of the result. Assignment. Write down the following assignment and give it a try on your own. Don't panic if you don't get it right the first time. Solve the following. Note. Calculate the rough estimates too, and compare them with the exact answers to determine the degree of accuracy. Work steadily, stay focused, and give it your best effort to the end. In conclusion, we have learned how to determine the degree of accuracy in measurements. In our next lesson, we will learn about percentage error. Great job, keep giving it your best. Remember, hard work always pays off. Thanks for joining me today. Goodbye for now.